Hey everyone, Ben Newton from Macro Connect here. Today's lesson is designed to go in tandem with lesson number 5 in the student-facing Code to Compose workbook. So lesson number 5 covers nesting, repeats, and sample customization. Now we'll get into what each of those means here in a second. Just know that by the end of this lesson you'll be able to repeat blocks of code for finite durations. You'll be able to effectively chain multiple commands together, and you'll be able to manually stretch and set the duration of the samples that you're using in your compositions. So let's jump right into it. Our first new coding command that we're going to be covering here is very similar to the live loop. As you may have noticed when instructing the last lesson with live loops, one of the blessings of a live loop is that you can repeat something to go on forever, but it can also be its curse, especially when students are just stuck with the same idea repeating over and over, getting kind of caught in a rut, if you will, in their composition. So there's another way to get that desired effect, except have it not go on forever, but a amount of times that we get to choose ourselves ahead of time. So in order to do that, there's a command called number, or I call it number.timesDo. Now, the number, obviously, we will put a number that we pick in there, followed immediately by a period, and then the word do. So, for example, let's say we have a very short melody that we want to repeat. All we do, essentially, let's say we wanted to repeat 3 times. We'll write 3 dot times space do. Now, if you recall, anytime that we have a do in Sonic Pi, there must also be an end. So know that everything after this will be repeated 3 times, and then it will be done. It'll be done, or it'll move on to the next piece of coded music that you have there. So let's just quickly type in something here that we want to repeat, just for an example. Could be anything here, by the way. And again, end. Notice how this will auto format. There you go. Now this is a nice visual cue that everything in this block of code is going to repeat 3 times. Let's take a listen. So there you go. It's repeated twice. And I'll play one more time. And we're done. So perfect. So again, this could be as much as 2 times. It could be 1,000 times. 10,000 times. Doesn't matter. It's up to you as the composer, as the coder, to decide what you want to do. But again, the times that this comes into play in terms of being more useful is when you want to start introducing the typical components of a song to your students. So choruses, pre-choruses, verse, all those sort of things. If you have students that want to do a more traditionally structured song like that, they can, for their verses, they can say, all right, 12 times do, followed by a pre-chorus of 4 times do, followed by a chorus of 8 times do, back to their verse of 12 times do, with their ideas encapsulated in between each of those number times do commands, if that makes sense. So it's very useful. You can use it in tandem with live loops as well, if you just want to have a drum beat in the live loop, but you want to have the parts of your song not be repeated forever and ever. This is the way to do it. So, on to our next coding command. This one is not so much of a new command as it is a new concept to introduce. It's called nesting. So, you may notice something familiar here. Previously we just introduced number times do. This idea that we typed before now has a 2 dot times do. This is going to play twice. However, instead of standing on its own now, I mentioned before, you can put this command inside of a live loop. So, if we're reading from the top, we want a live loop. So when we hit play, this block of code is going to play 2 times, followed immediately by these 3 notes. Then it's going to loop again 2 times, 1, 2, these notes, and it'll go on forever. So that is another way to do this, and it becomes very important. Now what this word nesting essentially means here is you may have noticed before when we've used live loops, there was no extra indentation here. But as you can see, we have one word do here, followed by another command that uses a do and an end convention. And remember the rule, anytime there's one do, there needs to be an end. So we read two do's here. Of course, we see two ends. Um, the reason that it is indented twice here is that it's just supposed to be easy for you to see that you are two indentations into a nested block of code, and it will only get rid of this indentation once you end one of these. And then it will only come to the very end to indicate that you've closed out your block completely when you end it again. So what this sounds like is this. Noticing that this plays twice, followed by this descending line right here. And that's how you can nest different commands inside of a live loop. That becomes important in this lesson as well as in the one that follows. So, the next question that your students are asked in this lesson is how to make this particular sample sync up, and you'll see what that means in a second, but how do you make it sync up by guessing what the sleep duration needs to be in this live loop? So, what that means, right now, we have a live loop called breakbeat. We have a loop prefix sample, which most of the loops have a varying length to how long each one of those samples are, from a few seconds to up to 8 seconds, that sort of thing. And they're all very tough numbers to guess. Now they're in the documentation for Sonic Pi. Students don't know that at this point. So what I mean by this is students have to guess how long to make this sample sleep in order for it, when it starts again, when the loop starts again, how are we going to make it sound perfect? And they'll realize very quickly through experimentation that it's pretty hard. So take a listen. This might be a foreseeable guess, but there is this big period of silence here. Then the sample loops again. So students are led to think, okay, what about half of that? Let's see if sleep 2 works. Almost, but there's that little stuttering part at the end of this loop. So, of course, students will then be led to go a little bit lower. Oh, but now it's too short, and the loop begins before the sample can conclude. And now we have a sort of sloppy sounding loop that just makes it hard to work around and hard to work with and add to. So once students realize that this is pretty tough, they're introduced to a new command. So what they can do is manually decide how long they want any sample to be. And how do they do that? Something called beat stretch. The way it works is we do a same line command, so same as a lot of these that we've learned about before, amp, pan, etc. You put a comma after the sample that you want to dictate how long you want it to be, and you guessed it, beat, stretch, colon, space, and now we get to pick a number that's going to be whatever we want it to be. So we know that the sample itself is somewhere around 1.75 seconds long. So let's just say beat stretch 4. We press enter, and now we've set this beat's duration essentially to 4 beats. So in 60 beats per minute as default, this is for 4 seconds. So we'll write sleep 4. Now let's play it. So based on what we discovered before, stretching it to 4 is going to make it sound super slow because we know that it was originally around 1.75. So if we wanted it to sound pretty close to what it was to begin with, we can make it sleep 1.75. It'll sound something like this. Maybe a little faster than it was. The point being, if your students are making a song and they're using, factors of 1, so they'll do 0.25, 0.5 for their sleep durations, or they want to just have multiples of 1 and use sleep 2, sleep 4, that sort of thing. Making it a nice square number makes it easier to manipulate and work with. Notice how the sample plays for 2 seconds. The sleep is set to 2. Everything works perfectly. So that's one way to do this. The other way to do this is not called beat stretch, but it's called sample duration. So this is just a roundabout way of doing exactly what we just did, except it's a way to just tap into SonicPi's ability to know exactly how long each sample is without having to set it manually ourselves. So these are both similar ways to get to the same conclusion. So if we use this breakbeat the same way we have, we want to sleep it, and we know that it's somewhere around 1.8, 1.75, however long it may be. But instead of guessing now, we can write sample underscore duration. Now this familiar drop-down list comes up from when we look for samples. We know it's going to be a loop prefix. We'll find breakbeat. Lo and behold, now the sample is going to sleep for its own duration. So it's just a backwards way to instruct our program to look up how long this sample is, and that's how long we want our sleep to last. Let's take a listen. Now those are all of the new concepts that are introduced in lesson number 5 of Code to Compose. So you should be fully equipped to answer whatever student questions come your way. Hope you and your students enjoy this lesson, and happy coding.